Hi, let me introduce you to the library vevestaX, which is the easiest library in the world to track machine learning experiments, features, as well as automatic EDA in a spreadsheet. The way to install this library is to do pip install vevestaX, which installs the library on your machine in your environment, Python environment. Now let me deep dive into a code where I have used vevestaX. So what you can do here is you can import the library vevestaX here, create an object V. After that, like any other data science project, read the data frame in a pandas data frame. You can also use a Spark data frame and then extract the column names here. So what the way we do it is v.ds equal to df. Ds is short form for data sourcing. It basically extracts the features that are there in the data frame. Then let us do some feature engineering. So I've done calculated acidity ratio here. Again, we do v.fe equal to df, or fe is short form for feature engineering. And when we print v.fe or v.feature engineering, we get acidity ratio here. Now let us track the parameters, the computed as well as constant parameters of variables such as epoch, accuracy, between, and the way to do it is you write v start and v end, and in between all all the variables that have been declared here, constants or computed, get these values get tracked here. You can use v start and v end multiple times. So I've used v start v end again, and I've tracked additional values of F1 score, precision, and recall in addition to the older values. What you can also do is actually skip using vstart and vend, and in that case it will track all the parameters and all the constants that are used throughout the Jupyter notebook. After doing that, what you can do is you can do v.dump, and basically what it does, it dumps the whole experiment and does EDA into this file vevesta.dump.xls, which you define here. The alternate way of doing it is just call v.dump technique, use XGBoost, or whichever technique that you've used, decision tree, ensemble, uh, deep neural network, whichever technique that you have used, you can specify here and will dump everything into an Excel file, which you define here with a message. What we suggest you also do is you actually use v.commit, which pushes these experiments, parameters, and everything onto a tool, Vevesta. Now let me deep dive into this file, vevesta.dump.xls. I've uploaded it to Google Docs here, Google Sheets here. Let me just show you the Google Sheet that I've uploaded. So this is how the Google Sheet looks like. You have the data sourcing tab. In data sourcing, you see in experiment 1, all these features were used. Similarly, in experiment 9, all these features were used. In feature engineering, we were playing around with acidity ratio in experiment 7. This is not used. In modeling, we do experiment ID. Every time we run an experiment ID gets updated by 1. We have features that are used, timestamp when the experiment was done, all the parameters that were being tracked by us are recorded here. Then we have messages. What we have done is for every time you run an experiment, you track technique used, you write a certain message and a version in the parameter. The code automatically tracks the file name for you. So every time we run a code, we basically as data scientists tend to make multiple files for every run. So it tracks all those file names for you so that it's easy for you to keep track of which experiment was in which particular file and the timestamp for you. Now we come to deep diving into how we basically give you a peek into the data. This is a sample data that gets dumped here. Then we give you EDA in form of correlation. So you can see that a correlation matrix is being dumped in the Excel, which is color coded for convenience of reading, for ease of convenience, for to make it easy to read the correlation matrix. Then you have profile report, which basically tracks all these variables such as in the data frame, such as duplicate rows, missing cells, number of observations, the average record size in memory in bytes, and so forth. Also, we also give you a variable profile where for each of the features, we calculate these values: distinct percentage ratio, total memory size, zeros, maximum, minimum, and so forth. Then we do EDA, missing values, where you see that with the sample number and the column number. You see where the missing values are placed in the data frame. Uh, this is uniformly colored here because the data did not have missing values in the data set that we have used. Also, you have percentage of missing values per feature being plotted here. Again, this doesn't have anything because there were no missing values in this particular data set. Then we plot the numerical feature distribution where you can see this is the index in the file. As you can see, this is the index, and this is how the values are distributed in the file. So you see it's close to 15, and then it drops, and then again it climbs up to a higher value, which alcohol, I'm talking about alcohol feature. Similarly, for other features, you can see it here. Also, we plot the histogram. So each histogram gets plotted here in an Excel file for all the numerical features. And then finally, we have performance plots. So we were tracking various variables, computed and constants in the Excel file, as I showed you in the before in one of the tabs. So we plot those variables, or the computed and the constants, in form of how they have evolved over multiple experiments. So you can see the seed has been constant, accuracy has changed over the period of time. So this is how the tool looks like, the library looks like. We urge you to use the library and provide us feedback on vevestaX @vevesta.com. Thank you.